Good morning, periods 2 and 3 calculus class. How are you today? I hope that you had fun doing the integrals yesterday, and we're going to continue to integrate today. So we have a little more of a challenge today. We have to write our functions as powers of x before we integrate. Now you can find examples of this. Here we go. In your book on page 314 and number 3 and page 315, number 5, which I will actually do in this lesson. All right, so the first one, let's check it out. All right, we're integrating 1 over x squared. Well, before we apply what we learned yesterday, which was our power rule, we have to rewrite this as a power of x. So, as you recall, 1 over x squared is x to the negative 2 power. And then we just follow our rules that we learned yesterday for integration. We add 1 to the exponent, so negative 2 plus 1 is negative 1, and we divide the current coefficient by the new exponent. So 1 divided by negative 1 is negative 1. So we get negative x to the negative 1 plus c. And if you remember from yesterday, we can check this. If we multiply negative 1 times negative 1, we get positive 1. Keep the base the same. Subtract 1 from the exponent, we get negative 2. We end up with our original problem. So what did I just do? I just took the derivative to check and make sure we did the integration right. If we get back our original integrand, when we take the derivative of the answer, we did it right. Okay. Oh yes, and the derivative of the plus c, let me not forget, that was 0. Okay, next problem. We're integrating the 4th root of x cubed. So we're integrating x to the 3/4 power. Remember, the index is the denominator and the exponent on the x is the numerator. So we're going to add 1 to 3/4. And so we might as well do it with a common denominator. So adding 1 is like adding 4/4. So we add 4/4 to the 3/4, which is going to give us 7/4. So we take our coefficient, which you don't see here, but we know it's 1, and we divide it by our new exponent, 7/4. And the nice thing is, when you take 1 and divide it by a fraction, it flips the fraction. So 1 divided by 7/4 is 4/7. And our answer is 4/7 x to the 7/4 plus c. Hope that makes sense. And the next one. This one's a little more challenging. So let's take it step by step. This is an integral of 1 over 3x squared dx, which we need to rewrite as 1/3. There's my coefficient 1/3, but x squared is in the denominator, so that makes my x to the negative 2 power. So this is just a rewrite of this expression so that we can integrate it. And now we just follow the rules. Add 1 to the exponent, so negative 2 plus 1 will be negative 1. Divide the current coefficient 1/3 by negative 1. And we'll get negative 1/3 x to the negative 1 plus our c. Just a little note, if you look in the book, sometimes they take the 1/3 in front of the integral and just work on the antiderivative for x to the negative 2. You can do that. Pretend a 1/3 is just in the front, just integrate x to the negative 2, and then at the end, multiply the 1/3 back into your answer. It will come out the same. I kind of like to keep the 1/3 here and then just divide it by the new exponent, doing the 2 steps at once. All right, last problem. Now, last problem is a little challenging, but I think you're up for it. So let's take a look. So here we have, what do we have? We have a numerator and denominator. We have a rational function. And our numerator has multiple terms in it, 2 terms. And our denominator has a single term, which is key. So what we're going to want to do here, which you might think we want to do, is integrate the numerator and integrate the denominator. But guess what? No, you cannot. You cannot just integrate the numerator and the denominator. Instead, you need to split the expression into 2 fractions and then integrate. And so here's how we do that. We take the x over the square root of x, and here, let me actually do that. This will be one expression for us, x over the square root of x, there it is. And the other one will be minus 1 over the square root of x. And that turns out to look like this. And then we have to write it in terms of powers. So we have x to the first power over the square root of x, which is x to the 1/2 power. And then here we have 1 over the square root of x, which is x to the negative 1/2 power. And now let's look here. This is still isn't simplified. We could simplify this a little bit more because this x is really to the first power. And then we can subtract the exponents when the bases are the same and we're dividing. So 1 minus 1/2 is 1/2. So our exponent is x to the 1/2 here, and this still remains x to the negative 1/2. So all this was just simplifying this expression so we could work with it and find the integral. And now we just follow our rules. We add 1 to the exponent, which gives us 1/2 or 3/2. And then we divide the current coefficient, which is 1, by the 3/2. Okay, and then that will give us 2/3 x to the 3/2 for the first expression. Then we add 1 to the negative 1/2, which I'm doing here. And we divide the current coefficient by our new exponent, which will be a positive 1/2. And 1 divided by positive 1/2 is positive 2, but we're bringing down our negative sign. And there you go. Throw in a plus c, and we've got it. 2/3 x to the 3/2 minus 2x to the 1/2 plus c. I hope I didn't overload you on this, but I have lots of confidence that you could do this. And so guess what? Here we have an assignment. It's on page 319. It's 19 to 33 odd. And remember to check your answers in the back of the book. And if you have any questions on these or any that you would like me to do out in our next video, let me know. Email me. Okay, thanks. Have a great day.